Hello, intelligent coders. My name is Shawn, and I will be your instructor today. You are watching Lesson 4 of the Java for Beginners series on the Coding with Shawn channel. Before I say anything else, I want to go ahead and remind you that there are 3 lessons before this one as part of the Java for Beginners series. And if you haven't watched it already, or if it's been a while since you've watched those lessons, I would highly recommend you go back just to rebrief yourself on the different, because the first 3 lessons are part of really the most fundamental aspects of Java programming. And if you don't have those fundamentals, then it'll be very hard for you to program later on. So I would highly recommend you go back and just brief yourself on those lessons. And if you've done that, let's go ahead and talk about what we'll be doing today in this 4th lesson. We're going to be covering 3 main topics: Java data types, typecasting in Java, and operators. So as part of data types, we're going to be talking about the 2 categories of data in Java, primitive and non-primitive. And we'll also be talking about the individual data types and how they work. We'll also be doing typecasting, as I said, and we talked about typecasting already in the Python for Beginners series, if you've seen that. And so I think really with today's lesson will really help you see some of the similarities and differences between Python and Java. And finally, we'll talk about Java operators, which is basically we're going to be starting to get into arithmetic a little bit, and you'll start to see the mathematical aspect of Java and how that works. So if we're ready, let's begin. So the first thing you'll need to do, as always, is open up IntelliJ IDEA or whichever IDE that you choose to use. If it has been a while since you last used your IDE or last used Java, you can expect it to take a little bit longer than usual. It's nothing out of the ordinary. When your IDE opens, you should be greeted with something like this. It may or may not have some remnants from what we did in our last lesson. So let's go ahead and test this out and make sure that Java is working properly. So go ahead and put system.out.println. At this point, you should be pretty familiar with this. This is just our print statement in Java, one of the most basic things. We talked about this in the very first lesson. If you run it, we should be greeted with what we inputted inside of the quotes. And there we go. So if you get this output, then most likely Java and IntelliJ or whatever IDE you're using is working fine. So if that all worked well, great. If not, not a problem. Just go ahead and comment down below what the issues seem to be, and I'll do my best to help you out as soon as possible. So for those of you who are free of errors and everything is working good, let's go ahead and jump right into it. So we're going to be starting out with Java data types. So in our last lesson, we talked about how every variable that we initialize in Java has to be a certain data type. So to go ahead and give you a rebriefing on what we did, there were a few main data types that we talked about in our last lesson. Among them were int or integer. So we can declare one, int num equals 1. Another type was float. Float is for decimal numbers, so numbers with a floating point. So we'll put float number equals 1.99f. Another type was char, which stands for character, and that is for a character or a letter. Our next data type is Boolean, which is just true or false. This is a binary data type. So we'll say Boolean bool equals true. And finally, the last data type we talked about in our last lesson is actually a non-primitive data type called string, if you remember this. So string text equals coding. Okay, so this is very important what I'm about to say, so make sure you're listening carefully. In Java, data types are between two categories: primitive data types and non-primitive data types. In primitive data types, we have many names that you might have heard before, including 4 of these: integer, float, character, boolean. There's also double, long, short, and byte, which are some that you might not have heard of. Don't worry, we'll get to that very soon. But basically, primitive data types are these simple ones that you've most likely heard of before. And the other type are non-primitive data types. So can you go ahead and try to guess which one from these is a non-primitive data type? If you guess string, you are correct. So string, arrays, and classes are non-primitive data types. Public class main is a class, so that's an example of another non-primitive data type. And you'll really we are going to talk about string today, but we'll also start to talk about classes and arrays in future lessons. So let's go ahead and first talk about primitive data types. So a primitive data type is defined as something that specifies both the type and the size of a given variable, and it has no additional methods with it. So there are 8 total primitive data types in Java. I'm going to go ahead and list them out here as comments. So the first data type, primitive data type, is a byte. A byte is equal to 1 byte in terms of size, and it stores whole numbers from the number -128 to 127. You absolutely do not need to memorize that it stores from -128 to 127, but it's just something I'm going to go ahead and let you know so that you'll start to get an idea of what these data types are good for using. So a byte is something that you might expect to be using in just an average small number. The next primitive data type is a short. So a short is equal to 2 bytes. And a short stores whole numbers from -32,768 all the way to 32,767. Positive 32,767. So short has a much bigger range than byte, but when it comes to larger data sets, short also is for numbers that aren't terribly large. Moving on, we have the data type int, short for integer. And this has a size of 4 bytes, so you'll see we're increasing in size. And this stores any whole number between negative, and this is going to be really long, 9,223, 372, 036, 854, 775, 808. So this number is 9,223,000,000. So this number is 9,223,372,036,000,000. So this number is 9,000,000,223,372,875,808. It is an absolutely enormous number, which means that int has a tremendous capacity. So this is negative, and it can store any number between that and 9,000,000,036,854,854,775,807. This is why I was telling you guys that you absolutely do not need to memorize this, because not only is this rather useless information to keep in your head, but also it's accessible to you on the internet at any time. And I can guarantee you that if you are in a Java class or something like that, you will never ever be quizzed on the capacity of an integer. And if you really want to remember, the only thing you need to remember is you can say from negative 9 quintillion to 9 quintillion. But again, you will never be asked that. And if you ever do have a quiz that asks anything around that, you will have access to the internet for sure. Moving on though. So an integer stores any whole number between negative 9 quintillion. So an integer stores any whole number between negative 2,147,483,648. And it's from that to 2,147,483,647. Again, this number is completely irrelevant. You won't be asked it. But I'm telling you this so that you know that an integer has a pretty large capacity. In terms of small data sets, really just any basic thing that you might be doing as a beginner, it's pretty unlikely that you'll need to store anything that's not storable in the capacity of an integer, but it may happen. And if it does, we have something called a long. A long is 8 bytes, and it stores whole numbers from, and this is going to be a very long number. I'm going to go ahead and tell you it, but remember, you absolutely do not need to memorize this. There's no purpose in memorizing it. You'll never be asked it. The number is negative 9 quintillion, 223 quadrillion, 372 trillion, 36 million, or billion, 854,775,808. This number is absolutely enormous, and it can store pretty much any practical number that you might be facing when you're programming in Java. And it's from that to positive 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854,775,807. This number is also enormous, and it means that really, again, I'm going to reiterate this one more time, pretty much any practically sized number can fit within a long. Moving on, we're going to get into a little bit of a more manageable data type. So that's going to be the float, which is our fifth primitive data type. A float is 4 bytes, so we're going back down now, and it stores fractional numbers. So we talked about earlier how floats are storing decimal numbers. Remember that decimal numbers are decimals because they are fractional. So we could say fractional or decimal numbers. And a float is capable of storing up to about 6 or 7 decimal digits. Stores up to 6 to 7 decimal digits. The next data type is a double. So a double is basically the same practical thing as a float, but it's basically the same relation that int has with long. Basically, an int and a long are both storing the same numbers. They're both intended for storing whole numbers. However, int has a slightly smaller capacity and long has a slightly larger capacity, and float and double have the same relation. Double also is intended for storing fractional or decimal numbers. However, it stores up to 15 decimal digits. So that's definitely a little bit more capacity than float. Moving on, this is going to be one you're probably a bit more familiar with, Boolean. Boolean is 1 bit, so it's the smallest data type so far, and there's only 2 possible values for Booleans, as we've said before. It's either true or it's false. Alright, moving on to our 8th and final data type, char or character. A character is 2 bytes and it's intended for storing a single letter or ASCII value. So these are our 8 primitive data types. Now before moving on, I want to say something that you're probably never going to hear again, but I think this is something that's very important to practically know. So I think, so a question that I've been asked a lot by students is int and long are both intended for storing whole numbers, right? Float and double are both intended for storing fractional and decimal numbers, right? So then, if I want to declare a whole number, why wouldn't I just use long instead of int? After all, it stores everything that int stores as well. Or why don't I just use double all the time instead of float? After all, it can store everything that float can too, right? And I mean, when you say that, yeah, you are technically right. Everything that can be stored by an int can be stored by a long, and everything that can be stored by float can be stored by a double. But the reason that you don't want to use it when it's unnecessary is because of memory. So Java is a very memory conscious language, and when you do use Java programmers really do like to be aware of how much memory they're using. And the thing is, when you're using a long instead of an int for something that's only, let's say we're trying to store 1 million, well, even though we're only storing 1 million, which would take 4 bytes, we're using an entire 8 bytes to store the same number because long is already making up its whole capacity. Its capacity is, again, that 9 quintillion number. So you have all that available storage and you're only using a fractional part of it. So though we're not using all our storage, we still have it as part of our set, which is just really, it's very impractical because it's just a complete waste of memory. So that's the reason why when it's not necessary, you should always opt for the smaller data storage option. That's something that I'm sure will definitely help you out as you continue into your Java journey. So before we continue on, I'm going to go ahead and give you an exercise. So here it is. I want you guys to try and add the correct data type for the following variables. Go ahead and pause the video, and I will give you the solution in 5 seconds. Okay, so let's go ahead and get to the solution. The first one, my number, is an int. Integers, remember, are for whole numbers that are not too large. So int my number is equal to 9. The second one, my floating point number, is a float. I'm really hoping you got that one because it was in the name. The next one, my letter, is a character. So char. Moving on, my bool, and I'm hoping you got this one too, is a boolean. This one should hopefully have been a little bit easier because my bool has it in the name. Booleans are very important, so do make sure that you're aware that anything that's true or false is a boolean value. And finally, my text is a string. Remember that a series of characters is a string. Alright, so how many of them did you get? Go ahead and give yourself a score from 0 to 100 based on this. If you got all 5 correct, that's 100. If you got 4 of them correct, that's an 80. If you got 3 of them correct, that's a 60. If you got 2 of them correct, that is a 40. If you got 1 of them correct, it's a 20. And if you got none of them correct, that's a 0. So go ahead and tell me what you did, how you did in the comments. I would say that if you got at least a 60, then you're doing good, but I would go ahead and recommend that you go back a little bit and just go through it briefly once more to make sure that you have a grasp on this concept. So if you've done that, let's go ahead and move on now. So we are now going to be talking about numbers. So we talked about how primitive number types, no, we didn't talk about this yet, but primitive number types are divided into 2 groups. So, like we said, that data types are divided into primitive and non-primitive. Primitive number types are also divided into two groups. It might seem a little bit confusing, but trust me, it'll all make sense. So there are two primitive number types, integer and floating types. So integer types are those that store any whole number from any positive or negative number that's whole. So we could say, for example, 264 or negative 932. Anything as long as it doesn't have decimals. Types that are part of integer types are byte, short, integer, and long. Which type that would you use between byte, short, int, and long is going to depend on the numeric value, as we talked about earlier. The other primitive number type are floating point types. So a floating point type is going to represent a number with a fractional part. So if a number has any decimal part that has at least one decimal, then there's two types for that. There's a float and a double. I talked about earlier, it just depends on how many numbers there are after the decimal. Okay, so as I just mentioned, there really are a good few numeric data types in Java, but let's be practical. Most of the time what you'll be using are int for whole numbers and double for decimal or fractional numbers. However, I will go ahead and describe them all for you. So let's get through this quickly, because this is not that complicated since we just went through them in a lot of detail. So the byte data type can store any whole number from negative 128 to 127. So we can use this instead of integer or other integer types if we're trying to save memory, because saving memory, again, is something that we do have to focus on when we're using Java. So an example could be byte number is equal to 100. So we can print this out. System.out.println and number. So we'll go ahead and run this. Oh, and we do need to remember to put the semicolon. That is something that even the most experienced Java programmers forget sometimes. Alright, and we get 100 out. Do remember that the absolute maximum capacity is 127, and the furthest back you can go is negative 128. But if your number is between that, then this is great for saving memory. Short. The short data type is for any number between negative 32,768 and 32,767. So we can create, for example, short number, and we can give it 20,000 as its value. And we can print this out. System.out.println number. And you'll see here that it, again, we have to remember the semicolon, my bad. If we run it, you'll see it works just fine. Remember that it does need to be, again, less than 32,767, which means that there are going to be times when this is impractical. Now, an integer data type I think you'll probably end up using the most is int. So int is between around 2 billion negative and 2 billion positive. So for example, you can say int number is equal to 2 billion. Okay, and we can print that out. When you run it, you will get that output because that is a valid value for the integer data type. Alright, and the final integer data type is the long data type. This is the one with the crazy long capacity. Again, it's between about negative 9 quintillion and positive 9 quintillion, which means that it can support pretty much any value. In general, you would not want to use long unless you have a really, really large value. And you would only use it if int is too small to store it. So we can put long number is equal to, let's say, 15 billion. And make sure that you remember, or you end a long with the letter L. That's just something that Java has a requirement of. And we can print this out. System.out.println and number. Alright, and then we'll run this, and sure enough, 15 billion printed out just like that. Alright, so moving on, we're going to talk about the floating point data types. So there's only two of these. We'll breeze through this easily. So the two types are float and double. So we'll go ahead and put float number, and again, float should only be about 5 or 6-ish decimal points at maximum. So we'll put float number equals, let's say, 2.92. And again, for float, similar to long, you have to end it with the letter F, lowercase. And we can print this out. And before we print it out, let's go ahead and also do the double. So we can put double number 2 is equal to, let's say, 19.23456. And this you have to end with the lowercase letter d. And we can print this out as well. Number 2. Okay, and we can run this. And sure enough, it works just fine. And of course, when it does print, Java automatically removes the letters F and D that you had to put originally. Okay, so once again, let's go ahead and talk about whether when we have to use float and when we have to use double. So again, the precision is what matters when we're talking about which one of these we want to use. The precision of float is only around 6 to 7-ish decimal digits, whereas double has a precision of up to about 15 digits. So when you're doing calculations that have, I would say even if you're at 6 or 7 decimal digits, if you're almost maxing out the capacity of float, I would just go ahead and opt to use double, unless you have very serious memory issues. So generally, I would be using double over float whenever necessary. Let's now move on to booleans quickly, and this is probably going to be our quickest section because booleans are the most simple, probably the most simple data type in all of Java. So we declare a boolean data type with boolean. A little bit different from Python. In Python, we would just do bool. And so we can take the values true or false here. So we can say boolean coding, and we can set that to true. We could put another boolean Java is bad. We can set that to false. And then we can print these both out. System.out.println coding. And we can just copy and paste for time purposes. And we'll just change this to the other variable, Java is bad. And when we run this, you'll see that we get true and false representative of what we entered here. So Boolean values are mostly used for something called conditional testing, and we'll learn more about that later. But basically, when we're going to be using Boolean values when we're trying to, so think about how you make decisions. Let's say we're deciding whether we want to sleep. So what we might think is our work done? And if our work is done, if that's true, then we'll go to sleep. And if it's false, if the work is not done, then we might not sleep yet. So that's basically that's basically the purpose of Boolean values. Of course, that's a very simple example, but that's really what we're going to be doing with Booleans later on. And that's their main purpose in Java. If something is true, then do something else. If it's not, then don't, or do something completely different. All right, so the next data type we're going to be talking about are characters. So the char data type is what we use to store just a single character, and it must be surrounded by single quotes. In Python, we have the nice little advantage of being able to use single or double quotes, but in Java, it's a little bit more strict. We have to use single quotes. So let's say we want to say char my letter, and we want to set that to C. Remember that we must use single quotes because double quotes won't work. Okay, and then we can print this out. My letter. And when we print this, you'll see that we get just the letter C as we put in. Char does work with lowercase or uppercase letters. So if we put lowercase c, then we would get lowercase c as our output. So if you are familiar with some ASCII values, you can use those as well. And also I want to go ahead and show you something very cool that we can do. So instead of declaring each variable at a different point, we can actually declare them all in one line. So let's say we wanted to say char character equals 1. Character 2 equals 2, and character 3 equals 3. System.out.println character, and we'll just go ahead and copy paste this into our other lines. And we'll go ahead and change this to 2 and 3. Alright, and when we run this, you'll see that we get this. Now you might have had this work on your end, on your computer, and really what this depends on is your computer support for ASCII characters, as well as what version of Java and what version of your IDE that you have. So the thing about when we use character, and the reason that this didn't work is because our computer, or at least my computer, is trying to print this out as an ASCII value rather than just an integer, which is why this is showing this. But do know that this is a valid option when you do start to use computers that have ASCII values enabled inside of them. And we could do that in IntelliJ as well right now if we enabled it, but that would be a little bit time consuming, so that's why I'm skipping it. But do know that this is a valid option for you to do if the computer and the IDE support ASCII values. Okay, so we're going to not go ahead and do string for the moment for side time purposes, because I think we're all familiar with strings already. It's just any series of characters like hello world. But the thing about the string type is that it's used so much and it's so well integrated inside of Java functionality that some people tend to call it the 9th type of primitive data types, even though, again, make sure you know the string is a non-primitive data type. So the reason that that is the case is because technically the string data type of Java refers to an object. And the string object has some methods that are used to perform some certain operations on strings. Now, if you don't understand the term object yet, that's not a problem, and we will talk a little bit more about both strings and objects in a later lesson. So let's go ahead and quickly talk about non-primitive data types. So non-primitive data types in Java are also referred to as reference types. So instead of calling it primitive and non-primitive data types, we can also say primitive data types and reference data types. So the main difference between primitive and non-primitive data types are that primitive data types are already defined. They're predefined when we program in Java. However, non-primitive data types are something that we actually create. We get to create our own data type as the programmer. The only exception to this is string, which is why some people like to call it that 9th data type of primitive. Non-primitive data types are able to be used to perform certain operations, but primitive data types do not have that facility. A primitive data type always has a value, but non-primitive data types can be null, which means it has no value. A primitive type always starts with a lowercase letter, while non-primitive types always start with an uppercase letter. So for example, when we're using int, which is a primitive data type, we're going to have a lowercase I, but when we use string, which is a non-primitive data type, we would be using an uppercase letter. So when we declare string, we have to use an uppercase S, just as an example. So, okay, so, and moving on, the size of a primitive data type depends on the data type, while all non-primitive data types have the same size in terms of memory. So some examples of non-primitive data types, which you may or may not have heard of, it's alright if you haven't, are strings, arrays, classes, interfaces, and some others. We'll learn about all of these very soon, but for the moment, we don't need to know that. You just need to know that they are non-primitive. So let's talk about typecasting now. We're moving on to our final segment of this lesson. So typecasting, you may know this term already if you watched our Python for Beginners series, but typecasting is when you assign a value of one primitive data type to another primitive data type. Typecasting cannot be done with non-primitive data types. I'll say it one more time. Typecasting in Java cannot be done with non-primitive data types. So in Java, for primitive data types, there are two types of casting. Widening casting, which is done by automatically, and narrowing casting, which is done manually. So widening casting is something when you're converting a smaller type to a larger type size. And the reason that this is considered automatic is because when you're changing something to a larger data type, you don't need to do anything. Because again, think about if you're converting an integer to a long. Because a long has a larger capacity than integer, you're not having to actually remove anything from an integer to make it a long. However, when we're doing narrowing casting, we may have to cut some things off if we're moving to a smaller data size type. Alright, so let's go ahead and put this into an example for widening casting. So it's done by itself when we're moving from a smaller size to a larger size. So let's say we're creating an integer, my integer, and we'll set that to 5. And then we can create a double, and we'll do my double. And we can say my double is equal to my integer. And when we do this, we are assigning not 5, but my integer to my double. So let's see what happens when we print this out. We'll do my integer. And we'll also do my double to see what happens. Alright, so let's go ahead and run this. And look at what happens. So because because the double data type is intended for decimal points, we do get 5.0 as opposed to 5 with integer. But notice that we had no issues, and by itself we were able to get the same, technically the same value using widening casting. So let's also now try narrowing casting. So narrowing casting is something we have to do by ourselves. So let's say we're creating a double this time. So we'll do double. My double is equal to 5.67. And again, we have to put a d at the end. And then let's create an integer. My integer is equal to, and here's the thing that we have to do differently here. We have to put int in parentheses before we put my double. This is a requirement of manual casting or narrowing casting, because we have to do it ourselves since we're moving to a smaller data type. And then we can print these out. So system.out.println my double and system.out.println my integer. Alright, and then let's go ahead and run this. And there we go. So I think something that's very important to know here, this is going to be absolutely critical to know. So we get our double back as 5.67, but when we convert it to an integer, we got 5. So what's so important about this is that notice we're not rounding. If we had rounded, we would have went to 6. But because we didn't round, we went back to 5. So really what this when we're manual casting, when we're doing narrowing casting in Java, we're not rounding, we're truncating. What truncating means is we're basically just cutting off the decimal point. We're taking 5.67 and we're just removing everything after the decimal point. Regardless of rounding, there's no rounding whatsoever. We just cut off whatever is after the decimal. That's very important to know, and make sure you have that in mind. Alright, and so before we do finish, there's one last thing we're going to do, which is operators. So now we're going to start to get into a little bit of arithmetic. I think this is going to be great for you math lovers, and even if you're not a big fan of math, this is going to be pretty simple, trust me. So operators are used to perform mathematical operations on variables and values. So let's do an example here. We can say int x is equal to 100 plus 20. Alright, so let's go ahead and run this and see what happens. And notice first that nothing gets printed, which means, and the reason I did this first is because we just wanted to see if there were any errors that were thrown, and there were not, so we can proceed to go ahead and print this. Print x, and we'll run this, and notice that we get 120. So Java went ahead and added it for us, and it gave us the output of that when we ran it. So usually, what we use the plus operator for is to add together two already defined values. Like, for example, what we did in this example, we did 100 and we added 20 to it. But we can also use it to add either a variable and a value, or two variables. So let's say we put int x equals 100 plus 20. Well, we can say int y is equal to x plus, let's say, 80, and then we can say int z is equal to x plus y. And then let's go ahead and print out all three of these to see what happens. So we'll run this, and look what happens. So we got our 120 as usual, and when we added 80 to it, we got 200. So we didn't have to define anything. We didn't have to say 100. We could just say x to put our 120, and we added that to 80, and sure enough, we got 200. And then int z, this one also worked, and in this case, we're using both variables, so we're adding 200 to 120, which is, of course, 320. So it's very interesting to see how many options and flexibility you have with Java. So there are a few groups of operators in Java. I'm going to go ahead and tell them to you, although they're not going to be important just yet. They are arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. Now, I'm telling you this right now, but just know that for the moment, it's not too important. So we're going to continue with this in our next lesson, but before we do, and I'm just going to go ahead and tell you what the arithmetic operators are. And in our next lesson, we'll go ahead and talk about the other operators. So in arithmetic operators, we have addition. So addition is used with the plus operator, and it's used to add together two values. Our next data type is subtraction in arithmetic operators. That is the minus operator, and it's used to subtract a value from another, which is the same thing as in addition. So, and then our next type is multiplication. I'm sure these are just the most basic types. You've probably heard of all of these things before in mathematics. We have the star operator here, or the asterisk, depending on what you want to call it. And this is used to multiply two values. Again, very simple, pretty obvious. And then the next type is division. So I'd say these four are the most basic of the arithmetic operators. You've almost certainly at least heard of them before, and they're very frequently and commonly used in mathematics, and they're very important to know. And then, so these are now we're coming to our last three, and these are some that you might not have heard of, since they're a little bit less frequently talked about. So we have modulus, that uses the parenthesis operator, not the parenthesis, sorry, the percentage operator, and this is used to return the remainder of a division operation. Alright, so like basically when you run a division operation, you always get a remainder. That remainder may or may not be 0, but whatever it is, we get that with the modulus operator. And we'll talk about that more in our next lesson. Then we have the increment using the plus plus operator. And this is just used to increase a value by 1. Very simple. That's all it's for. And the reason that the people who made Java took so effort to make this entire operator just to add to something by 1 is because in Java, you'll notice that, not even in Java, just in programming in general, there are a lot of times where you just want to increase something by 1 based on something else happening. So it's something that you'll probably learn to like as you progress in your Java journey. So the next type is decrement. It's used by 2 minuses. That's our operator. And it decreases a value by 1. So same as increment, but it decreases instead of increment. And that is the end of our lesson part of this video. So we talked about so much today. Let's go ahead and review. We started off by talking about what Java data types are. We talked about primitive and non-primitive data types. We talked about our number types, integer types, and floating point types. We talked about what booleans are. We talked about characters and strings. We also talked about our non-primitive data types, or our reference types, and the main differences between them. We learned how to typecast. We learned about how to we had to use widening casting and narrowing casting. So widening casting again is from going from a smaller type to a larger type size, and the narrowing casting is from going from a larger type to a smaller size type. And then we talked about Java operators. We started on it. We talked about arithmetic operators in particular, and we got through all the arithmetic operators. And in our next lesson, we're going to get through all of these and more. So definitely stay tuned for when Java for Beginners Lesson 5 comes out. For now, thank you so much for watching Lesson 4 of the Java for Beginners series. Thank you so much for your support, and that support is really what's allowed me to make this video as well as all the others. If this video was helpful for you, please do consider liking and subscribing. It helps so much. And leave a comment on what you thought of this video. Thank you so much once again, and I hope to see you in another video.